I'm Zach, Solutions Architect here at StackHawk. StackHawk is a DAST and API security testing tool designed to help developers quickly find and fix security bugs. It works by scanning your running apps, services, and APIs as an automated part of the software development process. StackHawk's solution is to automate and integrate DAST scanning into the software development workflow. In the ideal case, StackHawk runs on every pull request, surfacing security bugs on small code changes and grabbing the attention of the developer who just wrote the code. Then, we give developers the tools they need to understand, triage, and remediate those bugs before committing code changes to production. This means less work for AppSec engineers, less work for software developers, and less disruption to your product roadmap. In modern software development teams, developers open pull requests to formally propose code changes to an application. CI/CD automation picks up those code changes and builds the app. Automated tests check the app for errors, and at this stage, StackHawk can check for new security bugs in the running application, almost like an automated penetration test. If all automated tests pass, the PR moves on to peer review, and if enough stakeholders sign off, the code can be merged and the updated application moves on towards production deployment. But if any tests fail, we want to break the build in order to stop the PR and alert the developers so they can address the issue before continuing. StackHawk can optionally break the build at this stage when new vulnerabilities are found and draw the developer's attention to new security findings. The developer can triage those findings, for instance by creating a Jira ticket to be added to the backlog for prioritization. Or, more commonly, the developer can make use of our remediation tools to quickly reproduce, analyze, and fix the vulnerability. Then validate that fix locally, and then commit the fix back to the PR to go through the process all over again, this time hopefully passing all automated tests. Adding StackHawk to the developer workflow in this way short-circuits the delay between the introduction and resolution of a security bug from weeks or months to minutes or hours, all before the bug reaches production. Here's an overview of the StackHawk solution. It starts with your running web application. StackHawk works on any application listening via HTTP or HTTPS. It can be a REST API, GraphQL, SOAP API, single page app, classic web app, or gRPC. You can use OpenAPI documentation, GraphQL schemas, SOAP WSDL files, a classic spider, and an AJAX spider for single page apps. You can even inject custom data into OpenAPI variables for deeper REST scans, using known values for things like user IDs or group IDs to scan deeper into parameterized API routes. And if you have test data from dev tools such as Postman collections or Selenium scripts, you can use those to discover known paths as well. Next, let's talk about our scanner, HawkScan. HawkScan is portable and built for automation. It runs on Mac, Windows, and Linux, and is optionally delivered as a container image. HawkScan comes up on demand, reads its configuration from a YAML file, scans the target app, and then goes away. There's no dedicated infrastructure to install or maintain, and you can run it in your CI/CD platform, in the cloud, on-prem, in Kubernetes, and even on your laptop. That means you can get HawkScan up and running quickly. Better yet, you can get HawkScan behind your firewalls and rate limiters, and close to your target app for low latency scanning. That's how we're able to cut scan times to a tiny fraction of the legacy scanners, making it practical to run in CI/CD. Finally, HawkScan streams its results to our online platform. There's no dedicated infrastructure since it lives in the cloud. The platform collects scan results for analysis and provides tools for developers to fix vulnerabilities quickly and triage them if necessary. It also provides tools for AppSec engineers to review the security posture of all the applications tracked in the system and quickly zoom in on problem areas where they can focus their efforts. Here's a demo of how a developer might run the scanner locally from within their development environment. What you're looking at is my IDE, VS Code. On the left, you can see all the files in the code repo for my test app, VulNode Express. And in that list of files is the StackHawk configuration file, stackhawk.yaml. By keeping the scanner config in the repo, it's always available to developers who want to scan this app locally. And it's always available to automated workflows that operate on this repo, such as CI/CD. Finally, the configuration is versioned along with the software code in the repo, so you always have a history of changes to it over time. Up top, I have the configuration file open in my editor. The configuration language is YAML, which is familiar to developers. My example configuration is simple, which is a great start, but in true Agile fashion, we can layer on changes here over time, adding things like app authentication, OpenAPI documentation, scan tags, and more. Down below, I have my terminal window where I can run the scanner with a simple command line, hawk scan. I've already started up my application and it's running locally on my laptop, so let's give it a try. As the scanner starts, it validates my config, tests authentication, and discovers the target app, in this case using our basic web spider. If anything goes wrong here, the scanner will fail quickly so you don't waste cycles on a scan that isn't set up correctly. When the scanner finishes, it prints out a summary of findings. In this case, we have an error because the scanner discovered a new high criticality finding which crossed the threshold we set in the configuration file. The scanner also returned a non-zero exit code, which will break the CI/CD workflow, so the developer will know there's a problem they need to investigate. To see our results in the platform, we can click the link at the end of the summary report. We'll come back to these results in a moment, but first, let's see what it looks like in a pull request with CI/CD automation. Here's an example of a pull request in GitHub. In this one, I proposed a simple code change for my test app, 𝗦𝗽𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀. When I opened the pull request, CI/CD built and tested the app, including a DAST scan with StackHawk. Using the StackHawk GitHub integration, the StackHawk bot posted the results of the scan back to the PR as a comment. And in this case, you can see that the StackHawk check failed because it found a new high criticality finding, which exceeded the threshold we set for this application. You can even drill down into the finding details right from this comment, which is great because it means developers usually never need to leave GitHub. But in this case, since the check failed, let's jump to the StackHawk platform to see how we can address it. Here are the scan results as seen in the StackHawk platform. Along the top, we have the summary information that tells us the app name, the environment name, and the host we scanned, in this case localhost port 3000. We can also see when the scan ran, what version of the scanner we used, and there are badges to the right indicating that we have integrated static code analysis with Sneak Code and GitHub Code QL. In bright colors, you can see we have just one new high criticality finding, which is the cause of our PR check failure. And in gray, you can see triage numbers with 24 assigned findings and none risk accepted and none marked as false positive. Down below, we see all of the findings sorted by criticality and bucketed by finding type, such as SQL injection or cross-site scripting. In the SAST column, we show icons for any correlated static analysis findings from Sneak or GitHub, which can provide code-level clues useful for finding and fixing this issue. New findings are tallied under the new column, and triaged findings are tallied under the assigned, risk accepted, and false positive columns. Recall that the reason for our PR failure is because we have a new high criticality finding. And you can see here that the SQL injection finding is new and has not been triaged. So let's click into it. On the left side of our finding detail page, we have a developer-focused description of the vulnerability that we found. We describe what SQL injection means, what the risks are, and how to fix it. And in this case, we even have some cheat sheets with examples of SQL injection bugs in various languages, along with example solutions. And at the bottom, we list out all of the routes on which the vulnerability was found. Here's where you can triage the finding by creating a ticket, marking as false positive, or marking as risk accepted. On the right side, we show more technical details. Under the Evidence tab, we show the request that the scanner sent and the response that it received back from the target app. Under Activity, we show what triage actions have taken place for this finding. In this case, we accepted the risk a long time ago and then later unset that triage so the vulnerability is considered new. Under Sneak Code, we show any correlated static analysis findings with links back to the full Sneak narrative, which describes in detail how this bug is manifested in code. This is a unique feature that no other DAST vendor provides, and it gives the developer even more information to make it straightforward to find and fix this vulnerability. Under GitHub CodeQL, we show the correlated static analysis findings from GitHub. And Other Info describes how this vulnerability test works. The blue validate button constructs a curl command that the developer can use to reproduce the attack and confirm the vulnerability locally. And later, they can use this to quickly assess if they have fixed that vulnerability. With all of this information at hand, and given that PRs typically represent small code changes, the developer should be able to fix this vulnerability relatively quickly. With legacy DAST tools, findings like this won't make it back to the dev team for weeks or months, and at that point, it's often a lengthy investigation just to figure out where this bug is, much less how to fix it. Now that DAST scanning is running like clockwork in CI/CD, how can the AppSec team stay informed about the health of application security across the organization? Let's start with the Applications page. From here, we can see all of the applications in the system, and we can see a summary of scan results for each app by environment. I'm most interested in the 𝗦𝗽𝗲𝗸𝗶𝘀 application, so let's zoom in on that. This line shows that on our latest scan of 𝗦𝗽𝗲𝗸𝗶𝘀 in the development environment, we have 1 new high finding and 24 triaged findings that have been assigned to tickets. That little graph shows us how our findings have been trending in recent scans. The yellow bars indicate new medium findings, and red indicates high. The gray lines below the x-axis indicate triaged findings. So at a glance, you can see that in the development environment, we have been triaging a lot of issues, but probably not fixing much. So let's zoom in on the latest scan for this app and see what's happening. From the Findings Detail page, we can see that several issues have been assigned. Let's click in to take a look at the cross-site scripting finding to see what action has been taken on it. From the Activity pane, we can see that this was assigned to an engineering ticket by Zach. Now we have a trail we can follow to find out if this issue has been assigned, or added to a sprint, or worked on. We can reach out to the dev team to see if they need help prioritizing or fixing this issue. So that's how StackHawk works. To recap, StackHawk DAST integrates into CI/CD to alert engineers when they introduce new security vulnerabilities. Our architecture enables this, leapfrogging the competition with flexible deployment options, blazing fast scans, deep API scanning, and unsurpassed GraphQL support. And our SAST correlation is an industry first, giving developers code-level insights to help them resolve security bugs quickly. StackHawk is built for developers and the way they work. We make it easy for them to configure, run, and automate DAST. And we present them with the information they need when they need it to fix bugs before they reach production. At the same time, StackHawk gives AppSec teams the tools they need to oversee application security across the entire organization. To learn more, visit StackHawk.com. There, you can sign up for a free trial, and while you're testing us out, refer to our comprehensive documentation at docs.stackhawk.com. And when you're ready to put StackHawk to work for you, reach out to sales@stackhawk.com. Thanks.